Coefficient of rolling friction on inclined plane. Consider an inclined plane which makes an angle theta with the horizontal. Consider a rigid body of mass m
and radius r
is rolling down on this inclined plane with an acceleration a. Here, weight of the rigid body acts downward, that is mg, and this weight makes an angle theta with the horizontal. So we can resolve weight into its components. Its horizontal component mg cos theta and its vertical component mg sin theta. Here, this rigid body is in rolling motion. It is possible only under friction. So here, frictional force will act opposite to the direction of mg sin theta along the surface of contact, that is F. And this mg cos theta is balanced by normal force, that is N. So here this rigid body is rolling down. So we can calculate net force by using Newton's second law, that is mg sin theta minus frictional force is equal to ma. Here we can calculate friction from this step, that is F is equal to mg sin theta minus ma. So from this we can write mg sin theta minus m. In previous video we found acceleration is equal to g sin theta by 1 plus k square by r square. So here k means radius of gyration, r means radius of this rigid body. Now from this step I can write mg sin theta commonly outside. Then inside bracket I will get 1 minus 1 by 1 plus k square by r square. From the above step we can write mg sin theta, inside a bracket if we simplify, LCM will be 1 plus k square by r square. In the numerator, plus 1 minus 1 will be cancelled. If we do simplification, then we will get k square by r square. So we got friction, that is F equal to mg sin theta bracket of k square by r square by 1 plus k square by r square. So we know that F means mu n, that is coefficient of rolling friction into normal force, that is equal to mg sin theta. In bracket if we simplify means, that means if you move k square by r square to the denominator, then we will get 1 by 1 plus r square by k square. Now in the place of normal force, we can write mg cos theta. Then we will get mu into mg cos theta is equal to mg sin theta bracket of 1 by 1 plus r square by k square. Here both sides mg cancelled. Then we will get coefficient of rolling friction mu is equal to, if you move cos theta to the right side, then sin theta by cos theta we will get tan theta by 1 plus r square by k square. So we got coefficient of rolling friction, that is mu is equal to tan theta by 1 plus r square by k square. So that's about the session, my dear student. I hope you like this session. If you like it, please put like and share my video. Thanks for watching. Bye students.